Next, we will solve a problem based on different window. Okay, in the previous problem we go on with how a rectangular window function is going to be used. In this case we are going to use of our Hamming window. Okay, in this the given problem they already given what is the desired frequency response for low pass filter, and also they mentioned which window function, that is omega n, is we have to take. In this case they mentioned 1 for 0 to 4, that is 0 to 4 means what is the cutoff is going for. Okay, here it is given cutoff is minus pi by 4 to plus pi by 4. Okay, next we have to use our Hamming window. Okay, this is what the given data for us from this problem. In this case what may be the length? If we can you guess, yes, based on this we can guess that the length is 0 to 4 means m is going to be taken as 5 value. Okay, next to obtain our HD of n. Okay, how we can, they already given what is the desired frequency response, so that we can get our unit sample response from the desired frequency response, converting from frequency to the unit sample. Okay, from this is also a low pass filter. Use of the direct equation, that is HD of n is equals to 1 by 2 pi integration minus pi to plus pi HD of e raised to j omega into e raised to j omega n into d omega. Here they given what is HD of e raised to j omega, that is e power minus j 2 omega. I am substituting here. Okay, then e raised to j omega as it is. Then if we solve this we will be getting the equation, everything remains same. Here if we solve these two equations I will be getting as e power j omega n minus 2. Mathematically simple, you can do of these. Okay, just analyze here. Then again what is the integration of e power x, it's of e power x divided by 1, but here it is going to be taken as in the same way already discussed in the previous how it is going for, same e power j omega n minus 2 divided by the coefficient what we left is j into n minus 2. The limit is varying from minus pi by 2 to pi by 4 to pi by 4. Okay, if we solve for this equation, okay, if we solve this equation for n is, because here based on this condition when n is not equals to 2 you will be getting the equation as sin pi by 4 into n minus 2 divided by pi n minus 2. When n is equals to 2 you will be getting as 1 by 4. Okay, this is what you got HD of n. Okay, this from this equation we will get what is the filter coefficient of a desired filter. Next we have to find what is h of n value. Okay, here in this case they given what is the window function in the problem only, we are taking off that as it is. Okay, then what is the length? I already told m is going to be taken as 5. Just if it is 1 means just put the values of HD of n from 0 to 5, sorry 0 to 4, 0, 1, 2, 3, 4. Okay, HD of 0 if you substitute you will be getting as 0.159091. Okay, okay. Then if I substitute h of 1 you will be getting the next equation, next value. In the same way you will be getting h of 2, h of 3 and h of 4 values. This is what you will be getting of coefficient values of h of n, means h of n is going to be taken as HD of n multiplied with omega n. Okay, from this up to this we got. Next we have to find what is the h of e raised to j omega. To find that, we have to use the equation. In this case, frequency response for odd values. When we are going to use odd values, the m is going to change from m minus 1 by 2. Here is the equation. H of omega is equals to e raised to minus j omega m minus 1 by 2 into h of m minus 1 by 2 in plus 2 into summation n is equal to 0 to m minus 3 by 2 h of n cos omega n minus m minus 1 by 2. Okay, this is what the equation. In this case, substitute for m values as 5, m value as 5. The equation you will be getting as h of omega is equals to e power minus j2 omega h of 2 plus 2 summation n is varying from 0 to 1 h of n cos omega n minus 2. Next we have to expand this equation again. You will be getting 2 h of 0 cos, because n is going to be 0, cos omega minus 2 plus 2 h of 1 cos 1 minus 2 minus 1 cos omega minus 1. Okay. Then substitute the value of h of 0 from this, then h of 1 of these values. Okay. If you substitute, you will be getting this equation. After solving that, you will be getting as h of omega is equals to e raised to minus j2 omega into 0.25 plus 0.318 cos 2 omega plus 0.45 cos omega. Okay. Next, we will go calculate what is the magnitude response and phase response. Here the magnitude response is going to be taken as these values as it is, then phase response is going to be taken as e power which value we have. Okay, that is minus 2 omega when h of omega is greater than 0. When less than 0, it will be taken as minus 2 omega plus pi. What are the values we taken? It's not exact values. Okay, it's a pseudo values, a false values. Okay, to get the exact values, for that reason we are going to use of the Hamming window. In this case, using of Hamming window, this is what the equation for Hamming window. Okay, that is omega n is equals to 0.54 minus 0.46 cos 2 pi n divided by m minus 1. Okay, for n varying from 0 to m minus 1 value. Okay, what you have to do? We got our HD of n value already here. Then HD of n, we know what is omega n. Okay, omega n is taken from this. HD of 1 already calculated values, we have to multiply both so that I can get my h of n values. That is h of n is equals to HD of n into omega n. In this we have to substitute for n value 0, 1, 2, 3, 4. Okay, you will be getting omega n value, then multiply both values, you will be getting required coefficient for the given problem. Okay. Next, after getting these values, we have to find what is the desired frequency response. Okay, exact. Okay, here taken as for m is equals to 5, already taken this equation, again take that equation, e raised to minus j2 omega h of 2 plus 2 summation n is going to be vary from 0 to 1 h of n cos omega n minus 2. In this case, again expand the equation. Okay, then substitute the values for h of 0 as 0.01273. Instead of previously we taken those values, but here change those values by using Hamming window we are going for. Okay, then h of 1 we have to consider of this value. Okay, if you do that, you will be getting a desired frequency response of h of e raised to j omega as e raised to minus j 2 omega into 0.25 plus 0.02546 cos 2 omega plus 0.243 cos omega. This is what the problem given, and we calculated our frequency response also. Okay.